Okay, so I just wanted to kind of reflect with you all on this one. So yeah, the answer probably wasn't exactly what you calculated, and asked you all to kind of share your thoughts or share what you did. But I have an idea of some of the stuff that I hope that you all would have started to do. But you started to set up some proportions, like 5/12 equals some number over 10 gallons. So this was the 5 drops over the 10 ounces that we began with, and we got to get to 10 gallons. But we don't want the gallons to be the same, or we don't want these to be different units. We've got ounces and we've got gallons. So hopefully you did some work there too, using the conversion to get this to 1,000 or 1,280. And then hopefully you use what we learned with our proportions and figured out, like, what did we multiply 12 by to get to here? And whatever that is, we can take that and multiply and get to here. So you probably found something similar to this, but that was pretty close. If you multiply 12 by 165 or 6.5, you're going to get it really close to 1,280. It's not going to be perfect, but it'll be close enough. And we're probably not going to get an exact answer here, so any estimate is good. So that answer will get us, this will get us to 12 times 106, will get us to 12 or 1,278. So really close. So then what do we get up here when we multiply those together? So you're going to get W to equal 532.5 drops. So this is how many drops you would get. And this 0.5 would hopefully get you thinking about, how would I do half a drop, and how could that have caused our answer to be different? So you start thinking about those first 5 drops that we did. Were they perfectly the exact same size? Did one be a more larger drop? Was one a smaller drop? Are we going to get the exact same drop size every time? If we're using the tools that she was using, probably not. So unless we went and measured things out and we had tablespoons and we had, things that were really measuring precisely how many milliliters and things that we were dropping in there, it's not going to be perfect. And that's why our roundabout answer, where they got 518, is close to 532. It's close. And because those drop sizes may have been different. And any number that would have been over 532 would probably be very close in consistency as well. So did the idea of proportion still help us get to a reasonable answer? Yeah. If someone was to think that they could put 1,000 drops in there, well, they might as well just be eating right out of the flavor drops, because it's going to be too concentrated. But if someone was going to think, hey, I put 5 drops in that little cup, I'll just put 25 drops here. Well, that person's pretty much just going to have a very slightly diluted water. And I think we all know that that kind of is disgusting and probably not the type of water we're going to want. But either way, we can use proportions to get some really solid estimates. And that's going to kind of lead us into our next experiment or next challenge as well. But awesome job with that one. And you can celebrate with your partner if you all did a really good job with that. Great job.